Thank you for joining us. So we're going to be talking about some of the work that SUSE is doing with IndustryFusion. So my name is Andrew Gracie. I am one of the product managers in the Edge BU here at SUSE, and I'm joined by Marcel. If you want to.
Yeah, hello, Marcel Wagner from Intel, located in Munich, and working with Andrew and small and medium enterprises in the metal processing industry.
Nice. So today we're going to talk a little bit about who IndustryFusion is, and then what a process data twin is, what the solution architecture for what we're building for IndustryFusion is, and lastly, the roadmap, what we're building going forward. So a little bit of an introduction to IndustryFusion. IndustryFusion is a group of companies that have come together to basically build out a set of capabilities to handle equipment as a service and solve several of the pieces of the problem. Several of the problems. I'm going to apologize real fast. I've been just going for way too long. So it allows us. One of the main things that the IndustryFusion is focusing on is being able to sell equipment as a service. And the reason that you need that is that to be able to increase efficiency in your production, you need to actually be able to acquire newer technologies at a faster speed than if you had to capitalize those all the time, capitalize those expenses all the time. So upgrading poses just some major financial issues for the companies that need to do that, for specifically the manufacturers that would otherwise have to be buying these. So an example of these would be I've got this on my screen, but a fiber laser is 70% more energy efficient than a CO2 laser. That energy efficiency can really equate to a huge, both an offset of carbon costs as well as energy costs for these manufacturers. So when we're dealing with equipment as a service, we need to be able to actually handle how do you make sure you know when to buy the next piece of equipment? How do you make sure that you have to basically that you track all of the different pieces of equipment through the entire process. And that includes both the equipment itself, like the machines themselves, and the consumables in those machines. One of the case studies for IndustryFusion is air filters. So these air filter cartridges are very fancy, very expensive, but they do get used up as you go. So a couple of the challenges that we have once we start working through how do you actually provide equipment as a service is that you need to reduce the amount of trust. So you don't want to manipulate the data as it's being transferred. You need to be able to uniquely identify all of the assets through the entire process. We'll be talking about that momentarily. You need to be able to transfer data across company boundaries. That can be difficult to do in a secure way. And then again, you need to be able to create trust between all of the different stakeholders. That includes the manufacturers, the suppliers of the manufacturers, and the people funding the manufacturers. So some of the solutions that we have for that is we're using a process data twin, so PDT would be process data twin. That allows us to store a globally unique ID for that asset and then track it through the entire process. The IndustryFusion X, which is the overarching company here, allows us to be able to build out trust between the different players in this. It allows us to be more price sensitive and outperform. So lastly, there are a lot of companies that are involved in this. So including Intel here, SUSE, Ionos, and Dell. So I'll go ahead and hand it over to Marcel.
Yeah, thank you. Yeah, what's the challenge? Normally, when I guess we saw presentations from BMW today, and when you think about BMW, or when you go to the show factory, you see very nice and connected machines and very refined processes. But if you go to several 10, 20 kilometers outside of Munich to a smaller manufacturer, you are more likely to find something like this. Here you see two devices, two machines. One is a cutter, and the other one is an air filter. And how are they connected? With a dry wire. Means when you switch on the cutting machine, the air filter is switched on and working and running with full steam. And this can lead to interesting setups that, for instance, the air filter can run over a weekend because the machine is in standby and not really switched off, and you run into very inefficient situations. And well, it's obvious that this is one of many use cases where you can optimize, right? If you, for instance, knew more about the whole process, like what you do with the machine, then you could optimize the usage of the air filter. Yeah? For instance, if you know which material is cut, if you know the dimension of the workpiece, if you know whether you can blow out the air after filtering out of the building or it is retained in the building. So this has a lot of consequences. But you can apparently use it to save money and save operational costs. So it's easy, right? You can take a kind of IoT framework, you can collect some data, and based on the data you have, you can say, okay, I can reduce the strength of the filter because I know it's a small workpiece. And actually, that's what the project did. And then when it was presented some years ago, one guy stood up and said, you will not do that. Why will we not do that? This guy was from TUV, from TÜV, and saying, you break here safety rules, right? I mean, can you tell me what, where do you have the information from that you have a certain material in the workpiece? Where do you have the information from about the dimension of the workpiece? Where is it plausible? Can you rely on that? And for instance, you can have an automated process from the workpiece manufacturer, which is create the metal sheet about the material, and then you have a kind of scan system. That would be one source of information. But it can also be that the intern who just started at the company is entering this information. Then the trust level would be, of course, lower. And this is very important information you need to make automated decisions about even such simple things like controlling a filter connected to a cutting system. And of course, you can imagine there are even more use cases because this use case alone doesn't justify to do anything. Right? Maybe you can save 10K per year. Apparently, you need a platform, a framework where you can create similar use cases to save more money because for one use case, no one is investing. So we arrived at the conclusion that you cannot do it with a, let's say, flat IoT model. Of course, you can do it. You can do a lot, but the integration costs and the certification costs are too high. And that is how we arrived at a simple conclusion that you need to build up the whole project around a data model and not around connectivity. So you connect data, you connect in a certified way data, you map it to a data model, which you can then use to control, but also to validate whether your data is correct. And the framework which was selected from the project was the semantic web. I mean, the machines typically, or many of the machines have own connectivity, own ways to manage information. But you have also other sources of data, right? You have material ontologies. You have information from the human resources. You have environmental information. So you need to find a way to bring this all together. And in order to make a decision. So you need an integrative framework, a linked data framework to make this run. Therefore, you need data contextualization. And what is, or semantics, right? What is semantics? Actually, it's very simple. It's about information, about the surrounding information, and how you circumstances, for instance, how you created the data. And this is very simple. I mean, what is the data about? When the data was collected? Who collected the data? What is the quality of the data? Was it validated? And even down to the question, is it licensed? Can I reuse the data, for instance, for other purposes? But how do you do that? Sooner or later, everything you do with data is ending in a graph. Because your data points are connected to other data points. And you see an example of a graph. You have the data in the center, and then you are linked to other data or other information points or context points, which is, for instance, the location or the timestamp you have in timestamp and time series databases, or even the trust, right? Do you trust this value? And then those connections have then those edges have defined relationships to other data points. Yeah? And that is a very central experience when you work with data. Sooner or later, everything ends up in a graph and in linked data. So how do we then arrive at the semantic? So the semantic means you have data which is validatable and which is shareable, which means serializable. So you see the data comes, for instance, here from the machine layer. And at the bottom, you see typical machine layer data. And from the bottom, you come from a use cases perspective. Think about the filter case. So we realize that for instance, to judge whether the information is plausible is the workpiece, for instance, has it the right dimension, is created from information you don't have normally in, let's say, default information models. So your use case is creating more or different needs for information models or for information you want about your use case, about to solve your problem. So you cannot only rely on what the machines are delivering. But what you get from the machines, you contextualize it, you make sure that you know how the connection was, how the subcomponents were, but then you have to link it also with data coming from other sources, environment, ontologies, and so on. And at the upper part, you can then execute the use cases. So apparently you need a different way to look at data when you are at the machine layer and when you are at the edge or cloud layer, right? And here on the bottom, you see the typical specification, OPC-UA, Modbus for accessing machine data. And at the top, you see the specifications from semantic web. What is semantic web? Very short introduction. When you describe your information, you can in a nutshell say, I have subject, predicate, object. Right? This machine is owned by, or is of type, or has serial number. And if you do it like this, you realize that subject and object are nodes in a graph, and the predicate is the relationship between that. And you can serialize it. There are several ways to write it down and to share it with other people in a standard way. But if you start to combine it, you arrive at a very complex setup, right? On the right side, you see a single node, a single graph describing only one single material node in your factory, which is saying like, if you have a material of this kind, then you have so and so many different elements of so and so much percentage of a specific element, like chrome nickel. You have a vaporization temperature, and so on. And if you think about it, right, it gets more and more complicated. If you add more information, then you get a huge mess of a knowledge information, but also of your machines and entities you have. And that is why you need a concept, a framework, to not only to model your environment, but also to validate it, make sure that you really do the right thing, and that the structure you expect is really met. To manage your entities, there is another standard from semantic web called JSON LD. LD stands for linked data. What is it doing? Actually, linked data is you see here the structures which are 100% compatible with JSON, but it adds additional information in the JSON syntax so that you can link the data together and link the data with the semantic web. You see here, on our use case, we have a plasma cutter, which is linked to a filter, which is linked to a filter cartridge, and you have a workpiece. And what is very important, you can really group those graphs, like this belongs to a plasma cutter. It has a unique ID, and has a unique type, and it has certain property and links. And that applies to every entity you have here. But once you start to model it, you need to validate that you do the right thing. Yeah? For instance, when you have a data model, you need to make sure that the plasma cutter is linked to something which is really a filter, right? And both are fitting together. So you need a language to describe that the expectation of the data model are really where you can express the expectation to your data model. That is made by Shackle. So this is a standard from the semantic web. Shapes constraint language, you define the so-called shapes in your graph. So what is the structure you expect? And the system is checking, for instance, you see that is like a decorative way to describe on the right side what you want. And it's not a script or not an algorithm. It is only a description of your data. And here, this is a simple example for plasma cutters always connected to filter. But once you have the graph, you can then start to go through the graph. And so the arrows have been somehow screwed by the what was it? The docs framework. But actually what you can do, you can go, you have now everything connected, and you can compare the states of the system, of the cutter and the filter, and now you can describe those relationships and to make sure whether they are fulfilled or not. That has, for instance, safety consequences. But even more, you can now, even you have the whole graph, you can compare the workpiece of the material of the workpiece with the state of the filter cartridge. Right? And saying like, if the workpiece has a certain material, then you have consequences for the waste class of the filter cartridge. The filter cartridge is no longer something you can dispose easily. Now it is special. You need special disposal procedures because chrome or nickel has been filtered. And again, this you can describe with a declarative way in the semantic way, because you have a graph, and on this graph you can make shapes and statements. And now you put everything together. You have your entities, you have the knowledge, and you need apparently to validate whether the filter cartridge is now a special hazard, or you need special deposit of that. You can only know it if you, of course, can derive from the workpiece about the material, right? So you need the knowledge, you need the entities, and you need the description. To summarize, you need you typically have in such environment your knowledge graphs, which are done by RDF or OL. You have your entities, your live entities, which you can describe by JSON LD, which helps you to serialize and share the states of your entities. And you have a constraints language called Chuckle, which helps you to make sure that to define the rules, what is allowed, what can happen in your factory. And this gives you a very powerful way to manage your data and your constraints and your types in a live system. What does that mean? And offline when you share data, because the small and medium enterprises have not only so they are different companies, right? You must be able to share use cases and data between them. So you need a way to serialize it and to describe the constraints of the system. So this is the high-level architecture of the system. This is the real-time validation. Means the data comes in over the machines. Here you have a filter and plasma cutter. It is sent over MQTT and ends on Kafka. But you have also another way, because, for instance, the factory admin, or you have other apps getting access to the data, to the model. For instance, the factory admin is the person who makes sure that a specific filter is connected to a specific cutting system. And this is only something the machines, some machines know it, but in the SMB space, this is typically something which you configure manually. So you put it into the data model. So apparently you have live data which you stream, but you have also other places where data gets into your system. And here, as an example, the factory admin. The data arrives at Kafka and is mapped into the semantic model, which is managed in the broker, in the context broker. Based on the JSON LD, or more specifically NGSLD model. And the data on the data constraints are translated with the semantic SQL operator and run on Apache Flink, which is a real-time or low latency analytics engine, open source analytics engine. So all the constraints you create are supervised by Flink. All the data arrives at Kafka, and your current semantic data model with the entities is stored in the broker, and the changes of the system, like the matrix changes, but also the changes of the links and the relationships, are stored in the time series database, in this case, timescale.db. But you don't necessarily, because we work with semantic web standards. So this is only one way to validate data. So you have a real-time system, and you configure your real-time system with Chuckle, with the semantic constraints language, and you can get in data from MQTT, and of course you can export data in RDF and in JSON LD, and you get in real-time. So every sample, every change of your system is validated, and you get in a very short millisecond period the result of whether your system is breaking or your constraints are broken. But you can also go to an offline evaluation with that, because everything is serializable, so you can exchange the rules in a normal text file. You can exchange the entities, the current snapshot of the entities in the current text file, and apparently the constraints and the knowledge can also be serialized in a graph in a RDF text file. And so you can feed them into an offline tool, and then you can get the same output, like this is valid, that fits the data I see, fits to the specification, or and you can derive additional data out of that. Yeah, the semantic space is very powerful, but also hard to manage. No, that is why the IndustryFusion people found or created another way to handle or to get started with the semantic. That it means they have a tool which is creating their entities in JSON schema, and because JSON schema are typical ways in the IT world to describe JSON objects, and these things are then translated. The same you can do with OPC-UA. You can take the nodeset files and then map them into also into the semantic web. But apparently the semantic web is much bigger. And therefore, midterm, the IndustryFusion is creating tools how to really manage those semantic data, semantic web in a more generic way to make sure you can really make use of the full semantic web potential and capability. So, what are the use cases of that? We heard already equipment as a service. That is very key. And why is it so important for everyone to understand the concrete machine semantics and the environmental semantics? Because the more you understand as a kind of investor, the less you have to put money back to manage the risk. If you don't understand the risk, then the regulation is enforcing you to put more money on the table to manage the risk. And the more you understand, the less money you have to put back. Therefore, it's very, very important that if you build equipment as a service, to understand really the machine and the process. And not only what the machine is currently doing, but also the environment. But coming back to the TUE, to the TÜV case, right? This information can be used to have a live assessment, runtime assessment of safety regulations. Like, for instance, if you change something in your manufacturing, you don't want to each time to do a full safety certification, right? You need something which is observing the system and understanding the system and making a kind of pre-assessment whether this is still in the parameter of the approved system. But now when you can describe this in a semantic way, you can really describe whole processes and share processes between different people, right? So like you have a machine which is different companies, different factories. So you don't have a specific machine. You can make the first half of your process in one place and then go to another place, continue, and then come back, and you can describe it and you understand it, and the interfaces are clear. And finally, this way to define your environment with knowledge graphs, with entities, with semantic entities, gets help from the generative AI space, right? Because in the past, the question was always who's creating your knowledge, who's creating your knowledge graphs, who's creating your entities. Now, you have a helper, right? You have a co-pilot, which can help you, for instance, read documents and create knowledge graphs out of this. Of course, you have still to validate it, but it helps you really. It makes 90% of the work. You have, when you ask, for instance, ChatGPT, create me a shuttle model. It knows it, right? It's a standard. It can really create you those models and create me a JSON LD model. It knows it. It knows how to do it, right? And it's much easier to use LLMs now to help you creating your models and validating your models. Back to you.
And I'll actually add on to the AI piece that I'm typically not an AI believer, but because Shackle and the rest of the system is predictable and constrained, you know really easily if AI is actually producing something that is valid or not, and you have that check real time to be able to say, yeah, is this an output that is valid, right, and useful, and yeah, you get that additional safety there.
Yeah,
right?
I mean, we know that the feedback we get is you will not be able to certify large language models. It's impossible. What do you do, right? And then what you need is, I mean, yes, there are ways to say I can combine several ones, right? Still, you can't certify this. But therefore, you need, in many cases, a formal model, or a formal way to certify, to rule out that specific things happening, right? Otherwise, these are not certifiable. And yeah, that's a very important point. Thank you.
Yeah. Cool. So, am I on? Yeah, cool. Yeah, so we've put together an architecture, or IndustryFusion has put together an architecture that is both a cloud, has both a cloud portion and an edge portion. So the cloud portion that we have maintains all of the registration and all of the actual process data twin pieces in it. And then the edge portion, and sorry, something is crackling, but the edge portion then would host everything that's actually on site at the factory itself. And I'm pretty sure that, yeah, I've got a better, the edge portion is put together by SUSE, Intel, Dell, and a couple other vendors, and then the cloud portion is hosted in Jonas in their cloud at the moment. So some of the process, and I'm not going to go too deep on this, but when you when a new client comes and registers, they would register on the IndustryFusion X website. That would go through all of the manual steps. That would generate unique IDs for them to be able to use, create effectively a namespace, and this rendered really poorly. But that would go ahead and build out the right configuration hardware that they would need to procure the credentials that they need for that, and then they would be able to log in, connect to those gateways, configure them, and basically everything gets set up through this process. So part of the IndustryFusion, part of what IndustryFusion is doing is standardizing this whole process and giving it a way that as we're going through, we have a nice punch list to make sure that nothing gets skipped. Yeah, so when you're actually going to order and build out a factory, that's where you would order the hardware through IndustryFusion. They would deliver the hardware, and then this is where the SUSE part comes in, is that you would install the hardware. SUSE would, the SUSE Edge stack would take over at that point, register back to IndustryFusion using, currently we're using Elemental and Sleep Micro to do that. IndustryFusion would then say, hey, you need to create a cluster on this piece of hardware with this workload identified by by all of the IDs that we generated prior. That would then spin up all the right workloads to run and configure that asset and connect it in with the rest of the factory. Yeah. So for a roadmap.
Yeah. So this is not a technology roadmap, but it's more like what are the next steps? Where is it presented? When do they want to launch? So now IndustryFusion is about to start around summer with the first customers. So they are planning to go to the domain events like Euroblech and Schweißen und Schneiden, which are the typical domain shows in this domain in the metal processing area, so they now plan or now test the current release, and the plan is to until the end of the year to have. They have already some customers are really to do it commercially, so it's more like currently on trial mode, and then start next year really to scale it to more customers and build up more labs and factories to demonstrate that.
Thank you. These are all the components that we're using, these are all the components that are a part of the Edge management stack. We're working on specifically the one on the top right, Acri. We're looking to integrate that in with the IndustryFusion stack going forward. specifically because it allows us to automate a lot of the enumeration of devices and then running workloads that can connect to those devices and pulling data out, as well as wrapping context for what the device is, what the data is, all of that all together. Yeah, and then this is kind of maybe overly technical diagram of how that works, but what's really nice about Akri is that it allows for discovery and enumeration of really any device that you can write a handler for. Yeah. If you would like to get involved, contact us. Or check out industryfusion.org or on GitHub, IndustryFusion.